You think time flows the same everywhere. Tick, tick, tick. You imagine a single, invisible clock behind the universe, keeping everything honest. You think gravity is just a pull. Heavy things fall, light things don't, end of story. You imagine time passing inside gravity, untouched by it. As if time watches gravity from a safe distance. That picture feels obvious, comforting. It feels too basic to be wrong. But it is wrong, not slightly wrong, structurally wrong, because when time gets close to gravity, it doesn't stay neutral. It doesn't stay uniform. It doesn't even stay what you think it is. You assume time is the stage and gravity is the actor. But that assumption collapses quietly, without drama, and physicists were warned, not by experiments, by the equations themselves. Something unsettling happens when time meets gravity, and once you see it, you don't get to unsee it. You don't realize it, but you already believe something very specific about time. You believe it's always there, running in the background, quiet, reliable, identical for everyone. You wake up. Time has moved. You sleep. Time keeps moving. You never ask where it is. You never ask who it belongs to. You just assume there is one time, one rhythm, one invisible clock keeping the universe synchronized. That assumption feels harmless. It feels necessary. Because if time wasn't universal, how could events line up at all? So when you look at a clock, you're not questioning time. You're just reading it. Like checking the temperature of something that already exists. And if two clocks disagree, your instinct is immediate. One of them must be wrong. That instinct is revealing. Because it shows you don't think clocks create time. You think they report it. As if the real time is somewhere else. Hidden, waiting to be measured correctly. Physics believed this too. For centuries, time entered equations without resistance. A clean variable, same everywhere, same for everyone. Motion changed, forces changed, but time stayed untouched. And nothing broke. That's what made the belief dangerous. Because when an idea works too well, it stops being questioned. No experiment screamed that time was fragile. No observation hinted that it could behave differently in different places. So the idea hardened. Time became the stage. Everything else became the actors. But there was a quiet tension buried inside this picture. Time was being asked to be absolute, while the universe was becoming increasingly physical. And those two ideas don't coexist peacefully. You just don't notice the conflict at first, because the idea of a single cosmic clock isn't something you learned. It's something you assumed, and assumptions are the hardest things to let go of. You think you know what gravity is. Things fall, planets orbit, mass pulls on mass. It feels mechanical, almost intuitive. Something heavy tugs on something else. In your mind, gravity acts inside time. Time keeps flowing, and gravity simply rearranges where things go. That picture feels stable. It is wrong, because gravity does not behave like the other forces you're used to. It refuses to stay in its lane. Electricity pushes, magnetism twists. They change motion over time. Gravity does something more invasive. It interferes with the background itself. This is where intuition quietly fails. If gravity were just a force, time wouldn't care about it. Clocks would tick the same near a planet as they do far away from it. Only trajectories would change, but gravity doesn't settle for that. It doesn't just tell objects how to move. It tells them how long things take. That should feel uncomfortable, because time was supposed to be neutral. Untouchable, the one thing physics didn't mess with, but gravity doesn't respect that boundary. The deeper you are in a gravitational field, the more the universe behaves as if time itself is being altered. Not observed differently, not perceived differently, altered. This is the point where the old picture starts to fracture. If gravity can influence time, then time cannot be a universal backdrop. It must be part of the physical system. Responsive, context, dependent, which means gravity isn't something happening in spacetime. It is something happening to spacetime. That statement sounds abstract, but its consequences are brutally concrete. Because once gravity stops being just a force, it stops being optional. You can avoid electricity. You can shield magnetism. You cannot step outside gravity. And if gravity reaches into time itself, then no clock is ever truly isolated. Not even in principle. This is where physics began to feel uneasy, because it wasn't experiments that demanded this shift at first. It was consistency. The equations refused to let gravity remain polite. They demanded that time respond. And once you accept that, the idea of a single cosmic clock doesn't just weaken, it dissolves, because something that can be stretched cannot be absolute. Imagine two clocks, not symbolic clocks, not cheap, imperfect ones, perfect clocks, built the same way, calibrated together, ticking in flawless unison. You set them side by side, they agree, of course they do. Now you separate them. One stays far from anything massive. The other is lowered closer to a heavy object, a planet, a star. Something that pulls hard. Nothing dramatic happens. The clock doesn't shake. It doesn't malfunction. It doesn't know anything unusual is happening. Both clocks continue ticking calmly. Later, you bring them back together. And now they disagree, not because one is damaged, not because one ran slow mechanically. They disagree because they experience different gravity. This is the moment intuition panics. Your first reaction is denial. Maybe the setup was flawed. Maybe one clock was subtly affected by temperature, motion, vibration. But you can remove all of that. You can repeat the experiment, different designs, different locations. The disagreement remains, which forces an impossible conclusion. If both clocks worked perfectly, and both followed the laws of physics, then time itself must have passed differently for each one. This is not a metaphor. One clock genuinely lived through less time than the other. That sentence should feel disturbing. Because it removes your last safety net. You can no longer say, one clock is wrong. There is no correct time hiding behind the measurements. There are only local times, each tied to where the clock was. Time is no longer something clocks read. It is something they experience. This is where the old question collapses. Which clock is right? Is replaced by right for where? That shift seems small. It isn't, because it means time does not exist globally. It exists conditionally, and gravity is one of the conditions. Once physics accepted this, a quiet realization followed. If identical clocks can age differently, then time is not a universal currency. It cannot be exchanged cleanly between places, which means the universe is not synchronized. It never was. We just live in a region where the differences are small enough to ignore. But ignoring something does not make it unreal. It just makes it latent, and gravity is always there waiting to expose the difference. At this point, it's tempting to protect your intuition. You tell yourself a softer story. Maybe time isn't really changing. Maybe it only appears to slow down. A trick of measurement, a distortion caused by how signals travel. That explanation feels safe. It is wrong. Because the slowing of time near gravity is not observational. It is physical. Nothing needs to be watching. No comparison is required in the moment. The clock near gravity doesn't look slow to itself. It behaves normally. Every tick feels like a second, but when compared later, it has lived through less duration, not because information was delayed, because less time occurred. This distinction matters. An illusion disappears when conditions change. This effect does not. You can send the clock back. You can check it afterward. The lost time does not return. Time has been permanently reshaped. This is where language starts to fail. We say time slows, but that phrase sneaks in an assumption. It implies there is a normal speed somewhere else. There isn't. There is no default flow of time, no reference rhythm the universe respects. There are only local rates set by physical conditions. Gravity doesn't politely adjust motion while leaving time alone. It drags time itself, and it does so without asking, without signaling, without requiring observers. This is why physicists stopped describing gravity as a force. Forces act within space-time. They change paths, velocities, directions. Gravity changes the framework. Near massive objects, the future arrives more slowly, not metaphorically. Operationally, two identical processes run for different durations. This is not about clocks anymore. Chemical reactions slow, atomic transitions lag, biological aging follows along. Anything that depends on time is affected, which means you are affected, right now, just not enough to notice. That realization creates a quiet unease. Because if time can be slowed, it can be uneven. And if it can be uneven, it can no longer define a single present. The idea of now starts to stretch, and stretched things don't stay intact. This wasn't discovered the way you might expect. No one dropped a clock near a planet and watched it slow down. No dramatic experiment forced physics to surrender. The warning came earlier, quieter, more unsettling. It came from mathematics. When physicists tried to describe gravity honestly, without shortcuts, without pretending time was untouchable, the equations resisted. They refused to work unless time was allowed to bend. This is important. Physics did not choose to make time flexible. It was cornered into it. The equations could either be consistent or time could remain absolute, not both. That's the moment things turned, because mathematics doesn't care about intuition. It doesn't care what feels reasonable. It only cares about internal coherence. And internal coherence demanded a price. Time could no longer be separate from space. It could no longer flow independently of gravity. It had to become part of the geometry. This was the real warning. Not that clocks would disagree, not that time would slow, but that the very idea of a universal temporal backdrop was incompatible with gravity itself. The equations didn't describe gravity acting on time. They described gravity being a distortion of space-time. Time wasn't something gravity influenced. It was something gravity helped define. This is where the intuition finally breaks. Because if time is part of the structure, then it is not something the universe moves through. It is something the universe has. Locally, conditionally, unevenly. Physicists didn't celebrate this realization. They hesitated because they understood what it meant. Once time is absorbed into the physical fabric, it loses its authority. There is no master timeline to appeal to, no external clock to check against, only relationships between events. The equations were clear about this. Disturbingly clear. And once written down, they could not be unwritten. From that moment on, time stopped being a silent assumption and became a dynamic participant. And that changed everything, especially the idea of now. You believe in now more deeply than you believe in time. Past and future feel negotiable. Now feels solid. It feels shared. You assume there is a present moment spreading across the universe, like a thin sheet slicing reality into what has happened and what hasn't. That picture depends on one thing: synchronization, a hidden agreement about what counts as at the same time. Gravity breaks that agreement, because once time flows at different rates in different places, now, can no longer be exported. There is no way to declare a universal present without choosing a preferred location. And physics refuses to allow that choice. Near a massive object, time advances differently. Far away, it advances differently again. So which slice of time is the present? There is no neutral answer. What you call now is local. It belongs to where you are and how gravity is shaping time around you. Move to a different gravitational environment, and your present no longer aligns with someone else's, not because of delay, not because of communication limits, but because the structure of time itself disagrees. This is where language betrays us. We keep talking as if events happen in a universal order, as if the universe waits for permission before moving on. It doesn't. Events happen locally, order is contextual, simultaneity dissolves. This doesn't feel dramatic in daily life because Earth is gentle. Its gravity is weak enough that our disagreements in time are tiny. But tiny is not zero, and physics does not ignore things just because they are small. Once now collapses, time stops being a global organizer. There is no cosmic moment where the universe checks in with itself. Only countless local timelines, each internally consistent, none privileged. This is not a glitch. It is the natural consequence of letting gravity touch time. And once you accept that, the universe stops feeling synchronized. It starts feeling distributed, which prepares you for the final step. At this point, there is nothing left to rescue. No hidden reference time, no cosmic heartbeat, no external clock keeping the universe honest. The idea simply doesn't fit anymore. If time flows differently depending on gravity, and gravity exists everywhere, then time cannot belong to the universe as a whole. It belongs to places. It belongs to paths. It belongs to histories. Each region carries its own duration, stitched together with others only through physical interaction. There is no master schedule coordinating events, no universal moment where everything aligns. The universe does not ask, "What time is it?" That question has no meaning outside a location. This is where physics becomes quiet, because once you remove the master clock, you remove the last classical anchor. Reality is no longer something unfolding in time. Time is something emerging within reality, locally, relationally, without oversight, and here honesty matters. Physics does not fully understand time. It knows how gravity reshapes it. It knows how clocks respond. It knows how equations remain consistent. But it does not know why time exists at all, or whether it is fundamental or merely an accounting tool for change. What it does know is this: there is no external timeline watching the universe evolve, no background rhythm ensuring coherence, only correlations between events measured where they occur. That realization doesn't close the story, it opens it, because a universe without a master clock is not chaotic. It is subtle. Order exists, but it is negotiated locally, moment by moment. And once you see time this way, you stop asking when the universe is. You start asking where time is. And that question has no final answer, only deeper ones.